So you might be asking yourself or asking me, like, hey man, when would I actually use equations of lines in real life? Now, equations of lines, linear equations, and other types of functions can be used all the time for modeling situations or just in a useful way. So here's an example of where we could use what we know about linear equations to help us bid out a job. Okay, so we have Travis Scott here, who started a business framing houses in Beverly Hills, which have a zip code of 90210. Now, properly bidding a job is important. Otherwise, he won't get the job if you overbid, or he'll lose Benjamins if you underbid. You don't want to lose Benjamins, okay? Got to make that money, yo. Got to bring home the cheddar. All right, if he wants to make it to the upper echelon of home builders, he needs to bid jobs properly. His buddy, Lil Baby, has a little equation to help him bid jobs. He charges a flat rate of $1,000 plus $6 for every linear foot of framing to build the exterior of a single-story ranch out of 2x6s, and a flat rate of $700 plus $4 for every linear foot of framing to build interior walls. Let's properly bid the house pictured below. All dimensions are in feet. The house is 40 foot by 22 foot. Okay? A lot of information going on there, but let's see if we can properly bid this bad boy and set up an equation in doing so. That way, if we maybe expand something, expand the overall size of the exterior walls or whatever, we can just adjust accordingly. Okay? So first off, let's figure out the exterior dealio. So what's a fixed rate? What's changing, right? Our fixed rate, our flat rate, is the $1,000, right, for the exterior wall. So right off the bat, it's $1,000, and then you go from there based on the actual size of the house. Well, it's 40 feet by 22 feet, right, and it's $6 for every linear foot. So, it sounds like I need to know my perimeter, right? So if it's 22 feet here and 40 feet here, which is 40 over here, and then another 22 on the other side. So I'm running out of room over there, but I'll just put 22 feet there. Okay. That looks weird. And that looks weird. That looks a little better. Cool. So what's my total perimeter? I'm going to write that down. Perimeter is, let's see here, 80 plus 44. I'm looking at the opposite sides. That would be 124 feet. Cool. So what would we use there? So we've got our, well, it's $6 for every foot. So really we got 6 times that 124 feet, right? So I'm popping out my trusty TI-84. So 6 times 124 feet. That's $744 plus the $1,000. That would be $1,744. I don't know why I actually just typed that part in. Well, whatever. Okay, so we know that the exterior is going to be exterior equals $1,744. But what if, like, we made a change? What if someone's like, okay, well, I actually want it to be a 50 by 22 foot house, or a 50 by, I want to put it in a third bedroom back there, so I'm going to add on another 11 feet, and then even more. I'm going to have to keep on recalculating. Is there a way that maybe we could write almost like an equation or formula to make it a little easier to figure this out? And absolutely there is. So my consistent part is my $1,000. That's not going to change. It's $1,000 plus then 6 for every linear foot. So that 6 is my actual change, right? Or rate of change, or in other words, slope. Okay. So let's see here. I would have y equals, or you know what, why don't we say cost equals. So let's say cost, or C equals. Let's see here. And then my rate of change was the 6. And then X would be like my feet of linear feet of framing, right? So X. and then plus the flat $1,000 rate. And it's always good to label what these are. And I'm going to actually write C of X. You'll see that written in an algebra setting. C of X is cost per foot. X is linear feet of framing. Okay. Always good to identify your variables. All right. Oh, wonderful. Now, does that all make sense? Like, let's see here. Does that formula work out? Does this C of X equals 6X plus 1,000 work? Well, if I were to plug in 6 times, well, what was my linear feet? 124. And then plus 1,000, I plugged that all in my calculator at once, I'm going to get the same exact answer. If my person that wanted this thing bid it out wanted to increase the size, I would just increase the number I'm putting in for X, right? No big deal. It makes it a little bit easier that way. You can also show a customer, like here, as you increase the linear feet needed to frame your house, your cost goes up. You could give them a graph with that on there. That is some pretty dope stuff. All right. Well, it's also asking for the inside, right, which they use 2x4s in this case. And I'm kind of making these numbers up, the costs up. This is not necessarily realistic. I have no idea what it actually costs. So I just made up some maybe sort of close numbers. All right, so let's talk about our inside walls now. I'm going to go ahead and outline those in yellow. So I've got this guy, this whole thing, and this one. Those are my interior walls. So it looks like this is going to be 14 feet, right? Because if this guy was 22, 11 and 11 would make that up, right? Okay, so I got 14 feet there. This is going to be 22 feet. And then I've got 8 and 6, and it looks like I'm listing the 8 going this way and the 6 going this way. I'm just sticking with how the other ones were written with the 14 first as the horizontal direction. Okay. So my total inside framing, I would just add all those up. 6 plus 8 plus 22 plus 14. If we add all those bad boys up, I end up with 50 feet of interior framing. And if that costs, what was it, $4 for every linear foot, 4 times 50 is $200, plus the $700 initial, right? And that gets me a total of $900. But could I write a cost function like we did in the previous one so that if we did need to increase those numbers or decrease them, whatever it might be, based on a new floor plan design, that we could just pop it in the formula real quick and be good to go? And absolutely, there is, and many of you might already see what's going on. Let's see if I can just shrink this down a bit. I will do that and pop it over here, even though it's kind of a little weird. All right. Well, if I'm going to do that, let's see here. My cost of X, or why don't we do, we'll just keep it as a cost of X. This will be our interior. Well, it's $4 for every linear foot, so 4 times my linear feet plus my fixed rate of $700. Any of you guys know what that $700 or in the previous one, 1,000 represents? Well, that would be my y-intercept, right? That's my y-intercept on the graph. That's where it would cross the y-axis. Wonderful. That's good stuff. Now let's see. If I were to plug in my 50 for x, if I were to substitute my 50 linear feet in for x, would I still get the $900? Well, is 4 times 50 plus 700 still 900? In my book, it absolutely is. We still get the $900 on that one. That is not a dollar sign. That was a pretty cool one, though. Boom, there we go. All right, so it does work. Lovely. And again, you guys, we could do these without an actual function, absolutely. But just from a business standpoint, there are certain situations that are it's very beneficial to use an equation of some kind, whether it be a linear model or something else, to quickly get bids, quickly see what happens with costs as you increase certain components of a project. Okay, so these equations are very, very helpful in doing that. You might think like, oh, this is simple. I just put the numbers together. Yes, in this case it is, but we're starting with a simple example first, and then obviously it can become more complicated down the road. All right, we got J-Rock and Offset are trying to offset the cost of their new studio by hanging sheetrock, aka drywall, but I said sheetrock instead of drywall because J-Rock, themselves. A 4x8 sheet of drywall costs $10, and there's a $70 delivery fee. The studio is 30 feet by 50 feet and has some dope 12-foot high walls. Standard is like 8 or 9, man. 12 is super cool. Write a linear equation to help Offset figure out the cost of the drywall if he has it delivered. He'll call a guy to tape and mud for him. The contractor bid out $1,500 for the drywall. How much will they save by doing the work themselves? Alrighty. Well, let's see here. I think it'd be wise to draw a picture, or at least a rectangle, which I guess is considered a picture, right? So we got a 30 by 50 foot studio, and it is 12 foot high. All right. So let's see here. Well, first I'm thinking, I know we could really go through this and just do it without a whole equation, but maybe we could write an equation first and then plug that bad boy in, see it really work in action. Well, my cost as a function of x is going to be equal to what? And the C of x, guys, C of x is the same thing basically as writing y. They are interchangeable. We use function notation to represent certain situations like this, just like a notation. Like this reads, from a math person's perspective, the cost with relation to x. The cost as a function of x being our linear feet. Okay. So let's see here. Well, what's our variable cost here? What's changing? What's static? What's the same? Well, it's $10 per sheet. So if I figure out how many sheets I need, I would multiply that by 10, right? Boom, there's our slope. 10 times x being our number of sheets. And that's actually what x will represent this time rather than linear feet, will be number of sheets. Number of sheets of drywall. And then what's our static amount here? What's our fixed amount? That's the delivery fee. Okay? Sometimes they'll even eliminate the delivery fee if you order enough. We won't get into that. But we'll say it's a $70 delivery fee, flat fee. You order whatever drywall you want. It's going to be $70 to deliver it. Okay? Cool. So $10 for every sheet that we need. So what do we need to figure out now? We need to figure out how many sheets we need. Okay? Well, how are we going to do that? That's a wonderful question. Well, there are 4x8 sheets of drywall. And what you'll usually do, if you have like a wall, okay, I'm going to draw a new one with a wall here in purple. If I had my 12-foot high wall, 12 feet, so when I'm hanging my drywall, what people will do is often like stagger them, okay? And now they're 4x8 foot sheets. What would make sense here? I'm thinking I could divide this wall into 3 equal pieces. And how do I know that? Well, 12 divided by 4 equals 3. Okay? So 3 sections. And what I'll do is I'll have a 4x8 sheet like that. Another one there. But then here, I'll have a 4x4 sheet. Then a 4x8. Then a 4x8. And then up here, it'll be a 4x8 to start. And boom, like that. It almost looks like bricks right now, but they're 4x8 foot sheets other than this middle guy here to give you that staggered, not really look because you're going to tape mud, you're not going to see the seams. I believe it gives it a little more strength, you know. I've seen a lot of people do that. I don't know if everybody does that. People have their own preference for a lot of these things. Personally, that makes sense to me, but who knows? Maybe another guy would be like, dude, you crazy. All right, but anyways, we need 3 of them going up, right? Okay. And we're going to lay them, let's say, like that for sake of this problem. We got to figure out how many we need. Well, if it takes 8 feet, or if this covers 8 feet right here, and I got to go 50, right? 50, then 30, then 50, then 30. This sounds like a perimeter type problem. I'm going to find my perimeter. So if I do 30 plus, oops, that's a 3, not a 30. And I'm going to move this down here. 30 plus 50 plus 30 plus 50, or I can do 30 plus 50 and then multiply that by 2. I get 160 feet, right? And if I have 160 feet and each piece of drywall spans 8 feet, what would I do? Well, I'd take that 160 and I'd divide it by 8. And that's going to give me how many sheets of drywall I will need to cover that. You dig? Woo woo! So what's that give me? That gives me 20. So 20 sheets. But how many high? 3 high. And I'm running out of room, so I'm just going to have to take, let's see if I can just move this blue. Nope, I can't. Never mind. All right. So I got to take the 20 sheets and multiply it by 3. So 20 times 3, because I'm going 3 high, right? 3 high right there. And that gives me 60 total sheets. What can I do with 60? Pop it in my equation right there, right? Because X represents the number of sheets of drywall. So when I pop that in there, well, I'd have 10 times 60 plus the $70 delivery fee. That's going to be, what, 600 plus 70, which is 670. That's my total cost, or excuse me, Offset and J-Rock's total cost. And then they're going to install it themselves. And then they'll have somebody else come and tape mud. So how much did they save? How much did they save here? Well, how would I figure that out? Let's figure out our cash money savings. I'm just going to make that a little smaller. Well, the bid, right, the contractor bid out, and I'm going to do this in green because, we're going to be saving money. The contractor bid out $1,500, right? Their cost is $670. So if I subtract out the $670, I'm going to find out how much we save, and that's going to be $830. That is how much they're saving by doing it themselves. Now they can decide, hey, is that worth my time? Can I handle this job? Or should I just bid out the whole thing or have somebody else do the whole thing and the tape and mud, all that stuff? It just depends on the person. Cool. Either way, big thing here, guys, is writing this equation. That's what we're connecting to algebra and connecting what we're learning here in class and connecting the math to the construction process. So that's a big deal right there. Obviously, you can figure it out without an equation. But now, if we increase the studio space, we can figure out quickly what that total cost might be by just plugging it in the equation. And I could even graph it. So say this is my x-axis and this is my y-axis. If I were to, let's see, chunk this up by tens. All right, so I got my scale or my graph here. I'm going to scale it real quick. We'll go by tens on my y. 20, 30. And I'm going to go by ones on my x, and you'll see why in a sec. 1, 2, 3, 4. So think of the x as like my sheets of drywall. Sheets of drywall. And then the y is my cost. Right? So if I have 0 sheets of drywall, let's see, here we go up, it's going to be at $70. Well, why would I deliver nothing, but whatever, that's just where it starts, right? If I plugged in 0, I'd get 70. If I plugged in 1, I'd get 80, so I'd go up 10. Whoop, that did not land where I was hoping. I like that, it's a little better. If I went to 2, that'd be up at 90, and then 100, so on and so forth. And we're obviously not going to even see what we calculated, which was $830. That'll be way back up there. But you could graph that line and say, hey, as your cost or as your sheets of drywall goes up, your cost is going up by $10 per sheet, blah, 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 whatever. You could use it yourself or to show somebody when you're giving them a bid. Woo! That was awesome. I love this stuff.